This video, we're going to work another first order linear ODE. This one looks, I think, a bit intimidating because there's no y's, x's. That's one thing. It looks different. We also have trig functions. Um, First thing to note is we should identify that it is first order linear. There is my independent variable r. There's nothing happening to it. The theta in this case would be my x, my input, my independent variable. So this is first order linear. You should check, just to give you another reminder on an exam. I'm just going to say solve the ODE, and you'll need to recognize that it's a first order linear. So first we identify what p of x is. P of x is the number or the expression in front of r, in front of your dependent variable. So this is secant of theta. So to find mu, we have e to the integral of secant theta. Now you should right away, d theta, like, it's a secant, right? We could think 1 over cosine. We're going to have some problems. I'm actually going to use a table just to keep things simple. So what this integral ends up being, so we'll call it mu of x equals e, okay, and then this integral becomes ln of secant theta plus tangent theta. If this were to show up on an exam, I would give it to you. So you would have a table or something up front. The e and the ln undo each other. So we just get secant theta plus tangent theta. And then this is 4. Okay, if you think about when tangent and secant is just 1 over cosine. So we're thinking about when is tangent and cosine positive. Well, that's between negative pi over 2 and pi over 2. All right, we just think of cosine being an x. It's always positive on the right side of my coordinate plane, and those are the angles that cover the right side. All right, so what we're going to do from here is we now multiply everything by mu. I know it's not pretty at all, but we do it. So multiply dE by mu. All right, so we got secant theta plus tangent theta times dr d theta plus, and I'm going to go ahead and keep this simple where I don't have to write as much. You should multiply this out and check to make sure the product rule works on the next step. So multiplying both sides by that, we have the cosine on that side. If I think about cosine, so let's do this off to the side real quick. Cosine theta times, okay, it's going to be times secant theta. Secant theta is 1 over cosine plus sine over cosine. That's my tangent, right? This was the secant theta plus tangent theta, right? We just changed them to sines and cosines. When we multiply, we get a 1 plus, I put 1 sine over tangent, but I meant to put sine over cosine. Almost wrote sine again. Cosine. Here the cosines cancel, and we're left with sine. So on the right-hand side of this equation, it didn't get much more complicated. So 1 plus sine of theta. Now, that's great, actually, because this next line, we are guaranteed, and we could check this and make sure it's fine, but we are guaranteed secant theta plus tangent theta. If I do the product rule of that and r, then I get the line above. Right? You should check that. For the sake of video's sake, I'm going to leave it. Now, I have that set up, which is exactly what we wanted. We want to be able to take the integral of both sides because it's going to get rid of that derivative. All right. More writing than anything. And this is going to be d theta. Let me move this over. I need more room. Equals, all right, the integral of 1 plus sine theta, d theta. All right, the left-hand side is nice and pretty. It just undoes the derivative, leaving us what's inside. And then this is going to be the integral of 1 is theta. The integral of sine is negative cosine theta plus c. This is an implicit answer. We could solve for r, right, by dividing by that secant plus tangent theta. We should do that, I guess. So we get r equals, and this is the way I'm going to do it, 1 over secant theta plus tangent theta. Sorry for my bad fraction bar there. 1 over that, and then I'm just going to times it by this other side, minus cosine theta plus c. So there's a great answer. There's my explicit if I want it, or implicit would suffice. We also need to list our interval of definition. Interval of definition, I know it's kind of weird, but we already have it. It's negative pi over 2 to pi over 2. We determined it when we were dealing with these tangent and this 1 over cosine above. So there we go. There's our explicit solution to that dE with its interval of definition.